In today's lesson, we're looking at blood alcohol content. Your blood alcohol content, or in short BAC, is the concentration of alcohol in your blood. So alcohol affects a driver's judgment. This is basically your ability to think, okay, or reason and respond appropriately. It also affects the driver's concentration, which is the ability to focus, comprehension, so your ability to understand a situation quickly, and reaction time, which is the ability to respond quick. So a standard drink, okay, what that means is, for example, a mini of beer or a small glass of wine, and this contains 10 grams of alcohol in here. Okay, so you see that in a lot of alcoholic drinks on the label. They might say 1.5 standard drinks, 2 standard drinks, and so forth, depending on how strong that drink is. And the more you drink of that, the longer it takes for your liver to break down for you to drive again. So there are 2 formulas, one for male and one for the female, right? So BAC for the male is 10N minus 7.5H over 6.8M. And you can see that this depends on N, H, and N. And what are they? N in this case is the number of standard drinks consumed. Okay, H is the number of hours you've spent drinking, and M is the mass in kilograms. The only difference between these 2 formulas is the mass, okay, at the bottom, or the multiple of the mass, which is in this case 6.8 for the male, and for the female, it's 5.5, right at the bottom. And the reason is because males metabolize alcohol more efficiently than women. So given the same number of standard drinks and number of hours spent drinking for both male and female, okay, so the N and the H value are the same, okay, and the masses are the same as well, okay, let's just say all 3 things are the same, then the BAC of a male will be less than a female, okay? So basically, a female can easily get drunk more than a male. Right, so let's see how these formulas come into play. So example 1, Justin and Brittany. So in this case, Justin is a male and Brittany is a female. We're at a party for 5 hours. Justin, who weighs 75 kilograms, has 6 standard drinks, and Brittany, who weighs 58 kilograms, had 5 standard drinks. Who had the lower blood alcohol content? Right. So let's analyze Justin first, right? So for Justin, okay, he is a male. Your BAC formula is given by 10N minus 7.5H over 6.8M, okay? So N represents the number of drinks. So that is 6. H is the number of hours, okay, spent drinking. So they were at the party for 5 hours. So that's H. And Justin's mass is 75 kilograms. So we're going to substitute all those things in. So we'll have 10 times 6 minus 7.5 times 5 all over 6.8 times of Justin's mass, which is 75. Okay, now what that gives you on the calculator is around 0.0441, and we're just going to round that to 3 decimal places, okay, just so it looks nicer. So 0.044. This is his BAC then, right? So for Brittany, let's calculate her BAC, or black alcohol content. So her formula is given by 10N minus 7.5H over 5.5M. So the formula we're using is slightly different because she's a female. Then she also had, she didn't also have 6 standard drinks. She had 5 standard drinks this time. So it's 10 times 5 right there. I'll just point that out. Okay. How many hours did she spend there? 5 hours, and her mass is 58 kilograms. So let's substitute all that in. Okay, and this is over 5.5 times m, which is 58, right? And so her BAC will be 0.0391. So roughly speaking, to 3 places, that will be 0.039. Okay. So let's have a look at B now. If 7% of Justin's mass is blood, what is his blood volume correct to 1 decimal place? So the blood of a person depends on the person's mass. So Justin's mass here is 75 kilograms. So for part B, we're just going to get 7% of 75 kilograms. And what that will get you is 5.25 liters of blood, okay, in his bloodstream. Let's have a look at the next thing we're going to learn. So if you know a person who has a high level of BAC because they're under the influence of alcohol, over time, the body reduces the blood alcohol content. And the rate that it reduces this by is 0.015 per hour. Okay, so we've got to wait a number of hours for that person to reduce their BAC to 0 for them to drive or do everything safely again. So the number of hours before 0 BAC is reached is number of hours equals BAC over 0.015. And notice how this is basically the reduction per hour. Okay, for a body that reduces BAC by 0.02 per hour, the number of hours before 0 reached is BAC over 0.02. So in this case, this depends on the person's body, but mainly what we use is this. Okay, that's our formula we're going to use. So for example 2, Justin and Brittany from example 1 are both on provisional licenses or P plates. So this might be what you might be on. They stopped drinking at 11 p.m. at night and waited until one of them had a BAC of 0 and could legally drive home. Okay, who drove home and at what time? Assume BAC is reduced by 0.015 per hour. Right, so let's have a look for Justin. So for Justin in this case, in question 1, his BAC was equal to 0.044, right? So the number of hours it takes for his body to break down that alcohol content is going to be BAC over 0.015. So we're going to stick in that number, 0.044 over 0.015. Okay, so let me just do it on the calculator. 0.044 divided by 0.015. Okay, so that gives you like 2.933333. Okay, but once you press the degrees, minutes, seconds button, okay, which is this button here, you will get 2 hours and 56 minutes. So now we have to find out how long it takes for Brittany to break down her blood alcohol content down to 0. So in this case, Brittany's BAC, blood alcohol content, was 0.039, which is slightly lower. So the number of hours in this case is going to use the same formula. Okay, so we're going to have 0.039 all over 0.015. Okay, and so what that gives you is 2.6, or if you press the degrees, minutes, seconds button, you will have 2 hours and 36 minutes. Okay? So who took the quicker time? It will be Brittany. Okay? Her time is much lower than Justin's time. And the question says, who drove home? So Brittany, of course, and at what time? So Brittany would drive home at, and now what we've got to look at is this much time after 11 p.m., which is 1:36 a.m. Okay.